This is number 17 on sample final part 2. Suppose a projectile is fired from a cannon with velocity v0 and angle of elevation theta. The horizontal distance r of t it travels in feet is given by the following. R of theta equal to v0 squared times sine 2 theta over 32. And in this particular case, v0 is 80 feet per second, and the angle theta in radians, they want to know what angle in radians should be used to hit the target on the ground 84 feet from the cannon. So here's my good old cannon. It's shot off at some angle theta from the horizontal. And as the rocket goes, it has an initial velocity. And we want to know what that theta should be in order for it to land here at 84 feet from the target, given that v0 is 80 feet per second. Since r of theta is the horizontal distance, then we're going to replace r of theta with 84 feet and then solve for theta. So we have 84 feet is equal to v0 squared. So we're going to also replace the v0. So we're going to put in that 80 feet per second squared times sine of 2 theta all over 32. So if we multiply by 32 on the right and then divide by 80 squared, we'll have sine 2 theta isolated. So we have 32 times 84 all over 80 squared is going to equal sine 2 theta. So we're going to take the inverse sine to solve for 2 theta. So we have 32 times 84 over 80 squared, and we're going to take the sine inverse of that expression, and that's going to give me 2 theta. I'm going to let u equal 2 theta. And then what I'll have is that's the sine inverse of 32 times 84 all over 80 squared is going to equal u. And it turns out there's 2 places where the sine is going to be positive. Now the arc sine is only going to give you the angle in the first quadrant if this expression in the argument is positive. However, there's another place where the sine is positive. And that's not going to be just in the first quadrant, but it's going to be anywhere where the y value is positive. And so that's going to be anything above the x-axis. And if it's above the x-axis, that means it's either going to be in quadrant 1, which the arc sine will give you, or quadrant 2. So we know that u could be in quadrant 1, and then we can have u that's going to have that same reference angle that's in quadrant 2. So we'll call this guy here alpha, our reference angle, which if it's in quadrant 1, the reference angle will equal alpha. So we're going to get 2 cases. So let's go ahead and draw the second case in blue. And I'll label that one U2. So that calculator is going to give us the first one. Wahoo! So to get U2, it's just going to equal the answer that we get for the first quadrant response, which is just sine inverse of 32 times 84 over 80 squared. But since it's in the second quadrant, we want to make sure we subtract that answer from 180. So let me give myself a little more real estate. So that's what the second value will equal, or how we'll obtain the second value, is to subtract that answer from 180. So let's go out to the Alex calculator and find u in the first quadrant and then also u in the second. When you go out to the Alex calculator, you want to make sure you change it from degree to radians. And then when we evaluate this expression, I got u was equal to 0.433 when you round it to 2 decimal places, which is the nearest hundredth. So 0.433 is to the third place, but 0.43 to the hundredth place. And then to find the second angle, I had 180 degrees, but it really should have been for u2. Since it's in radians, it should have been pi minus sine inverse of, well, actually, why don't we just put in the 0.43? Well, no, we'll write it just the way it is. Sine inverse of 3284 over 80 squared. So we'll go ahead and do that as well. And so the best way to do this is I just use the undo button. And when I put in the undo button, I just put pi minus in front. And then when I evaluated that expression, I got the following. $2.708 and when you round that to 2 decimal places, 2.71. Now that gives us the value for u, but we're not asked to solve for u. We're trying to find theta. But if you recall, if you recall, u was equal to 2 theta. So then what we have is 2 theta equals 0.43 and 2 theta equals 2.71. So our two values for theta are going to be 0.43 divided by 2 and 0.271 divided by 2. So we'll get theta equal to 1.35 for our second case. I'll call it theta 2. And theta 1 is going to equal 0.217, and 0.217 can be rounded to 0.22.